Today, I'd like to talk about our research online discussion tradition analysis for group learning support. At the beginning, we introduce the background. The educational technology and learning science fields have recognized that group work as an effective method for higher order learning. Indeed, OECD and Japan's new guideline urge group work in classrooms. Recently, opportunities for group learning have been increasing on the online communication tools. Unlike face-to-face classes, online tools use mechanisms such as breakout room for group activities, which limits the participation of non-group members. While these mechanisms assist in group activities, teachers find it difficult to monitor all the groups at once. Thus, providing support for group learning and teachers is becoming increasingly important. Research has conducted on supporting teachers for group learning as a visualizing system study. Taufik etc. proposed a system using LDA to visualize learners' discussions. The system applies LDA to each discussion text and displays the words that constitute the topic with the highest probability. This study analyzed whether each group was adequately engaged in the discussion. This previous study aimed to assist teachers in providing appropriate feedback to all groups. By contrast, our study aimed to discover groups in which teachers should intervene. As the objectives of these two studies are different, they can be used at once. For example, if no group requires the teacher's intervention, the system proposed by the previous study could assist the group in better discussions. However, if the discussion is not going well, the proposed algorithm can help teachers promptly join the group in the middle of a session, organize the issues, and encourage learners to discuss. We then look at another study, topic detection and tracking. We call this study TDT. This study is similar to our study because both studies analyze whether unentered text has the same content as the previous study. A TDT algorithm is proposed for predicting future events after mining causal relationships. The algorithm analyzes whether the entered new text is on the same topic as previously reported news. If it is the same, the algorithm associates this latest news with the chain it has accumulated as news. This procedure is identical to discussion transition analysis of this study. In this study, if the entered discussion text is the same as the previous contents, our algorithm also accumulates new text. Otherwise, the algorithm discards the newly entered text. Although the process of TDT is similar to our study, TDT is not used in learning support. The objective of this study is to support teachers in monitoring student groups. This is the user interface of our supporting system. We analyze the discussion transition for each group. Depending on the analyzing result, we display yellow or red, like a traffic light, to implicate that the teacher should intervene to group. In addition, we present the main theme of each text like this, so that the teacher can keep track of what the group was conversing about before they intervenes. This is the overview processes of our system. In our implementation, we use Google Cloud Speech to Text to obtain all group discussion text. We then make the text tokens. To analyze the transition and the main theme, we extract entities and Wikipedia categories from the tokens. We then apply them to the discussion transition analysis and the main theme analysis. Finally, we show these results at the visualizing process. We describe the two analyses from now on. In this study, we set an assumption. Although the discussion transition happens over time, the change is continuous. To implement this assumption, we propose two models for discussion transition analysis. The first one is Q model that analyzes only the most recent NPCs. The second one is memory model that is inspired from forgetting curve. The image of our Q model is this. The green cloud represents words used in a discussion text. This model stores the words in the queues. To determine transition of the new text, this model calculates concordance rate between the new text and stored text. If the rate is too low or too high, the model sets a color for alert. We use Jaccard coefficient to calculate the concordance rate. As shown in this figure, if the square is too small, it is considered deviating. Conversely, if the value is too high, it is considered stalling. The memory model using forgetting curves to analyze the presence of or absence of repeated words. We achieved this idea by reducing the weight of less important words that are used only a few times and increasing the weight of important words. The decrease in weight is exponential, as shown in this figure. This calculation is performed for all occurrences, so a word that appears repeatedly will have its weight calculated many times. Calculating the sum of these values yields a relatively high value. The right figure shows that the weight of soccer is the highest among the three words soccer, sports, and Japan, because there are two occurrences of soccer. Next, we describe our main theme analysis. This analysis uses Wikipedia because the large number of articles on Wikipedia is useful for addressing all types of learning contents. To obtain appropriate Wikipedia data, we use explicit semantic analysis. If we use this analysis to this text, we obtain these three Wikipedia articles. We then extract their Wikipedia categories. After converting the categories to feature vectors by Dr. Beck, we calculate their center of gravity. We finally select the closest category to the center of gravity as the main theme of the text, like this. To evaluate our algorithms, we use W2E dataset. This dataset is created for TDT problem. As mentioned in the related works, the processes of this study is similar to TDT. Thus, we use W2E for quantitative evaluation. We use two methods as baselines. The first one is TDT for comparing accuracy of our discussion transition analysis. For this, we implemented the Radinsky's algorithms. The second baseline is LDA as for main theme analysis. We trained LDA model on the W2E dataset and created feature vectors by LDA's topic distribution. This is the result. Our algorithms obtained high accuracy in the analysis of adequacy and inappropriateness. In contrast, the two baselines obtained low accuracies that were about 30%. Thus, we can say that simple application of past studies is difficult for the objective of this study. This is a conclusion. In this study, we propose algorithms to support teachers in monitoring group activities. Experiments confirm that all of the proposed algorithms can be analyzed with high accuracy. Although time was too short to present all of the evaluation results in this presentation, we confirmed not only the accuracy of the proposed methods, but also the analysis time and analyzed the properties of the Q model and memory models in our paper. The short summary is that the proposed Q model provided faster results for discussion transition analysis, whereas the proposed memory model was more accurate. Thank you for your attention.